Okay, I guess the time has arrived. Welcome to day 2. In day 1, we talked a bit about the course in general and introduced the Python development environment, namely idle, and the interactive shell that you can type Python commands to. And we introduced the idea of variables and arithmetic, which is not particularly exciting, but exceedingly important to understand well. Anybody have any questions from what's today? Thursday, so that would have been Tuesday. All right. I do, by the way, record my lecture videos, and didn't have time to post Tuesday's recording yet, but I will post Tuesday's recording and today's recording either this evening or tomorrow morning. So if some of you have mentioned that you missed Tuesday, some people, I think, in fact, have just registered for the course just in the last day or two. So you won't actually have missed Tuesday after all. And if you'd like to review things from Tuesday, you'll be able to do that. Okay? Now, if you have just registered for the course, if you've just come off the wait list into the course, please do send me an email if I have not assigned you a homework partner for this week, and I'll make sure that you are assigned to a team. All right? Well, let's pick up where we left off. So we were talking about variables and arithmetic and arithmetic operators on Tuesday, and we talked about variables and values that you can store into variables and operators that you can use on variables or on values and so on. The lowest level types of data that you can manipulate in a Python program are referred to as the scalar data types, and these are individual integer values called the int data type, or individual floating point values called the float data type. What we mean by floating point is values that have fraction parts, numeric values that have fraction parts, whereas integers don't have fraction parts. We also have strings of characters. These are typically intended to be human-readable sequences of characters that you can, display to a user on the screen or something, or that the user would type on a keyboard to get input into your program. And we also have Boolean values, bool values that are either true or false. Those are the only two possible values for bool. Now, it is possible in Python for a variable not to refer to anything of any particular data type, and the special value for that purpose is the sole value none. So if you want to have a variable but you don't want that variable to be referring to an integer or a string or a list or a dictionary or some higher level kind of object, the only way that you can create a variable is to assign that variable to refer to a value, but you can use the special value none to say, all right, well, I know I need the variable, but I don't yet know what I'm going to use that variable for. Okay, so these are the basic scalar data types, the lowest level data types that we're going to be using in our programs. Now, strings can be enclosed in Python either in single quotes or double quotes. All right, so if I say hello in single quotes, that defines a string. And if I say hello in double quotes, that also defines a string. I guess it's kind of natural to wonder, well, okay, so why does the language give me two different ways of defining these things called strings? Well, as one simple example, let's imagine that the string that you're trying to represent has double quote characters as part of the string. Then you could use single quotes to contain a string that happens to contain double quotes. So hello, she said, you know, is a exceedingly short sentence from a book, let's say, and of course that has in English that has double quotes around the word hello. But in order to store that in our Python program, we have to have that in a string. Since the double quotes are part of the string, we can use single quotes to contain the entire string. And the same goes for double quotes. I can say something like double quote, don't divide by 0. Okay, this is a warning not to crash your program by dividing by 0. And in order to get that contraction, the apostrophe T as part of my string, I've chosen to use double quotes here to surround the entire thing. Okay, so having the ability to use either single quotes or double quotes to define a string in Python is simply a convenience. What's the next problem that you run into, though? What if you have a string that has both double quotes and single quotes in it? Then what the heck do you do? Well, it turns out that you can define strings by using triple single quotes or triple double quotes. All right, so for example, again, if I'm using Python to write a novel, which is probably an extremely stupid idea, I can say triple, 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 double quote, don't do that, he said. Okay, so here is my string. Don't do that, he said. And that string happens to contain both double quotes in it and one single quote in it. I can define that entire thing as a string to Python by putting triple single quotes around it. Or I could use triple double quotes around it. Now, what Python is displaying to me on the screen is what's called its internal representation of the string. And Python is, what's the word? Python tries to be quite concise in the representations that it displays to you. And so Python for strings typically won't display triple single quotes or triple double quotes. Instead, what Python is displaying to me here is single quotes to contain the entire string. And then it turns out that within a single quoted string, you can put a literal single quote by having a backslash followed by a single quote. All right, so I could have manually typed that myself. I could have said single quote, double quote, DON backslash apostrophe T, do that, double quote, he said, single quote. I could have matched up the single quotes around the entire thing myself, but then it's put on me to remember to put a backslash in front of every single quote that might exist within the body of that string. And that's just kind of painful. So when you are defining a string, it's common to use the triple single quotes or the triple double quotes just because they're convenient. But don't be at all surprised if what Python displays back to you as its internal representation does not use those triple single or triple double quotes. Everybody happy so far? Yay! All right. Now, the plus symbol and the times symbol do have meanings for strings as well as for numbers. Plus sort of kind of means addition, and star sort of kind of means multiplication. But in the case of strings, addition is interpreted as concatenation. And multiplication is interpreted as repetition. So if I say, well, let me hit the enter key here. All right, so if I say this is, and then plus a test, all right, I've got one string that I've defined within single quotes, another string that I've defined within double quotes, and the plus here is interpreted to mean that I want a single string that's a concatenation of those two strings. And so I get, this is a test. I should have put a space on one side or the other to maintain the word separation. But that's what the plus symbol does for strings. And then the star symbol means repetition. So if I say string ABC times 3, I get ABC, ABC, ABC. One of my favorite little tricks, if I'm working with formatted data where the column positions of the characters actually matter, and modern data formats like XML or JSON or CSV or various things like that move away from the importance of column positions, but you can still find a lot of data where the column position of each character matters. If you want to count column positions, well, if you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can just display that above your data to easily figure out, where columns 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are. And if your data is 80 characters wide, well, that's no problem. You just multiply this by 8. And now you can easily just read down, where your column positions are for the 80 characters in your data. Good? Okay. When you use a triple quoted string, you can actually type a string that's multiple lines long. And so this is very useful for like block paragraphs that you want to store or display for some user. Let me do that live here. So I'm going to say quote, quote, quote. And in fact, I can just hit the enter key right here. This is a paragraph. I should know better than try to spell long words while I'm talking. Paragraph of text that has 3 lines in it. Okay, so now I've got a 3-line block of text. Internally, in the representation of what I typed there, Python inserts \n, meaning new line, wherever I hit the enter key. So there's a \n before this is a, and then there's another \n, a new line between a and paragraph, and between text and that, and also at the end of the last line. Okay, so that's the internal representation that Python uses to keep track of that multi-line long string that I typed in. All right, everybody good with strings? Okay. Now, when you define a variable in Python, you just give the name you want the variable to have, and then you assign some value to that variable. Here I'm saying I gets none. Now that creates the variable I, and I is now referring to this special none object. So this is a little bit of a philosophical quandary here. None is supposed to represent no value. It's supposed to represent nothing. And yet it is a thing. None is a thing. It is actually an object that occupies memory. It's just a unique thing. It's the only thing in its data type. And I can ask, what is the type of I right now? Meaning, what is the type of the object that I is referring to? And I get told, that's none type. Now, in most languages that are common nowadays, when you create a variable, the data type of information that that variable can store can't change. That is, if you're using Java or C++ or C#, you have to say in advance, I want I to be an integer. And then I will only be an integer during the so-called scope of that I. But this is not true in Python. In Python, a variable is just a reference to something. And the data type of the something that the variable refers to can be whatever. So if I say I gets 5, that's fine. And now the data type of I, that is the data type of the thing I refers to, is int. Or I can say I gets 22/7. And the data type of I is now a float, or I can say I gets hello, and the data type of I is now stir. So the deal in Python is that objects have data types associated with them. Variable names refer to objects, but the variable names themselves don't have data types associated with them. And this is both good and bad. It means that it's very easy to create variables in Python. You don't have to make sure that you get your type declaration set up correctly as you do in other languages. On the flip side, if you want to use x to keep track of a floating point number, you can trivially and accidentally assign a string to x, and that's fine. That's cool. Python won't complain. It won't say, "Are you sure?" You know, it's just going to grind along, and now you have x referring to a string instead. Well, all of the examples that we've been doing so far have been interactively at the shell. That is, I've typed something at the shell, and I've seen some result appear on the screen. And this is fine when you're playing with stuff and learning stuff and experimenting with Python. But in real life, we would like to have our Python code contained in a file so that we can write, a sequence of Python statements that do something useful, and we can then re-execute and expand the sophistication of our Python program in the file. Yes?
Does Python have a null value?
None is the null value. Yeah. So, let's take a look at how we can write Python code in a file now, rather than just interactively playing with stuff with our shell. There are many, many, many integrated development environments available for Python. The very simplest one is called idle, and it comes with the installation of Python itself. And I like to use it for teaching because it is so unbelievably simple. It doesn't have a lot of fancy menus, a lot of fancy symbols, a lot of separate windows on the screen, and so on. So it's very easy for me to, show you what I'm doing in idle. But it's likely that you, for your own real development work, are going to prefer something more sophisticated, such as Spider, which gets installed with Anaconda, or PyCharm, which is a very popular integrated development environment that you can separately download and install, or something called Jupyter Notebooks. Okay, so there are a variety of different program development environments that you can use, and the one I'm going to use is just really simple. All right, so here's my shell, and in my shell there's a file menu up here. I can say File, New File, and that pops up my Python editing window, and it's exactly as mindlessly simple as Notepad. I mean, it's about as plain as can be. And in here I can type Python code, so I can say things like I gets 12, S gets hello, And when I save and run this program, that will cause the variable I to get created referring to 12 and the variable S to be created referring to hello. Now the shell, when I say I gets hello, and I just type I at the prompt, the shell's conventional behavior is to display to me the value of the last expression that I typed. All right, so I just say I, and the shell shows me what value I is referring to. This is not the case in the editor. If I want to see the value of I have to use the print function to see the value of I. And likewise here, I'm going to see the value of S. All right, so this is a mindlessly simple little 4-statement Python program. I'm creating I referring to 12, S referring to hello, and then I'm printing I and I'm printing S. I need to save this. I'll say save as, and I want to save this into my Intro to Programming with Python directory. Okay, actually, all right. That's from last year. So I'm going to create a brand new folder, and we'll call it Introduction to Programming with Python A1 2019. And I'm just going to call this thing Example 1. Now, I warned you that I'm teaching multiple Python courses and I'll get confused. Did I already show you an example 1 on Tuesday? No, that was a different class. Okay, good. So this is our first example 1. All right. All right, so I'm saving this thing as example 1. And now I can run it. I can go up to this Run menu and click on Run Module. And yay, the shell gets restarted. The shell is responsible for interpreting the program. And I is created referring to 12, S is created referring to hello, and the value of I, or the value that I refers to, and the value that S refers to are both displayed on my screen. Yay, now we can write programs. So far so good? Okay. Okay, and this next slide here, slide 8, is basically something I've already said. In the shell, if you have an object like A, if you have a variable name like A referring to a value, then all you have to do is type the variable name at the shell prompt and the shell will display the value. But with code in a file, you have to use this print statement instead. And I've used the print statement by just saying print I, print S, but you can actually give multiple arguments to the print function, and by default, the print function will separate those on your screen with space characters. So here we have something a little more interesting that we're doing. What we're doing here is converting a Fahrenheit temperature to Celsius. And we did this, I did this interactively on Tuesday, correct? But it's a pain to do interactively because if you make any mistake in any statement, you have to completely start over again. So this time, I'm going to put this into a file. And unfortunately for me, I forgot that I can't copy and paste from... Okay, so this is going to be F2C is the name of my file. And I forgot that I can't copy and paste from Acrobat. So I'm going to have to manually type this in. Oh well. All right, so I'm going to say Fahrenheit is 80. Celsius is 5/9, 5/9 times the Fahrenheit temperature minus 32. And then I will print the Fahrenheit temperature, and then I'm going to print the Fahrenheit temperature in Fahrenheit is Celsius. All right, so I've got an int, I've got a string, I've got a float, and I've got another string. And the print function is smart enough to be able to print all of those different data types in human readable form. And where I typed a comma in between these four arguments, comma, 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 in the output, instead of commas, I'm going to get a space in each of those places. So let me save this file, and I will again run it. I'll say run module. And yay, so I first get told 80, that's the Fahrenheit temperature, and then I get told that 80 Fahrenheit is 26 point repeating sixes Celsius. All right? Wow, a program that even does something. Now, in addition to accepting just plain variable names and scalar values as arguments, the print function is an example of a function that also accepts a few what are called keyword arguments. A keyword argument is an argument that has a predefined name, and you can say the name of that keyword argument followed by an equal sign and then the value that you want that keyword argument to have. For example, the default separator character that the print function uses is the space. By default, when you print a sequence of arguments, they come out with one space in between each value. But by saying sep gets comma, and notice that I have to use quotes to make comma into a string, that will change the separator. So let me now say, let me add a statement in here. Okay, so we're saying A gets hello. I want to do this in my code. All right, A gets hello. And then I'm going to print A and the string Bob and the value of Celsius. I'm sorry, that's actually the value of, what is that? 11/3. Did I miss a comma?
No, single quote on hello.
I did. Thank you. Yay! See, the advantage of writing code in a file is you can fix it rather than having to completely retype it. 11/3 true. All right. So 11/3 true, and if I display that, the values will come out separated by spaces. But if I display that and I also add sep gets comma, in that second print statement, where I'm printing hello and Bob, the values are going to come out separated by commas instead of by spaces. And let's confirm that that's true. All right, so I'm saving it. It turns out I can use a shortcut key. Instead of saying run module, I can instead just press F5 after I've saved the file. And it runs, and indeed, we see that here we got hello Bob and a floating point number and true printed out with spaces in between, whereas here, where I said sep equals comma, I get the values displayed with commas in between. All right, so you do have control over how print displays your stuff. Questions? All right. Okay, let's see. So we've seen examples of int, we've seen examples of float, we've seen examples of strings. Booleans only have two legal values, true with a capital T, false with a capital F. If you accidentally type, for example, true with a lowercase t, that is not recognized as the Boolean value true. In fact, Python will think that that's supposed to be the name of some variable, because after all, it's a sequence of characters that starts with a letter followed by letters. So since it's not a keyword in the language, it must be a variable instead, or some, the name of some object. And since I don't have any object whose name is lowercase true, I just get told, well, the name true is not defined. Okay, true with a capital T is good, false with a capital F is good, but not either of these with a lowercase initial letter.
How can we assign the true value to a variable? Do we have to put the quotes or do we directly?
Oh, excellent question. No, if you use, okay, that's really good, yes. If you use quotes, you get a string. So if I say B1 gets true in quotes, that thing is a string that happens to contain capital T, little rue. But if I say B2 gets true without quotes, now the data type of B2 is Boolean. Okay? Other questions? Okay. All right. Now, so on Tuesday, we looked at all these various arithmetic operators, multiplication, division, exponentiation. As a convenience, Python provides so-called assignment operators that are just directly stolen from C, Java, C++, all of these languages that originally descended from C provide these same things. So if I have S, oh, I don't have S anymore. Well, let me create an S, referring to hello. Let me try. Let me do something easier. I gets 123. So now I have this variable I, and if I say I plus gets 1, that is a typical way of incrementing I. So I is now 124 instead of 123. And if I say I times gets minus 1, I now have I being the negative of what it used to be. And if I say I star star gets 2, well, this is going to compute I squared. So whatever minus 124 squared is, that's going to become the new value of I. In other words, this is a shorthand for saying I gets I to the power of 2. Okay, so you don't technically need to know these assignment operators, but they're used all the time. They're convenient, and so you should be aware that they exist, even if you don't think to use them yourself. Okay, here are more examples. Now, a couple of these, namely the plus and the star, will work with strings as well as with numbers. So if I say S gets HE, and then I say S plus gets LLO, well, what I just did there has the same effect as if I had said S gets S plus LLO. So I'm just appending the value of S, which at that point was HE, and the value of LLO into the single string hello. The star for strings, of course, means repetition. So if I say a star gets 2, then I've got hello, hello in there. Make sense? Okay. All right, so we've now flogged our way through the so-called scalar or lowest level data types. We've got ints, we've got floats, we've got strs, we've got bools, and we have this one value none hanging around as well. We'd like to be able to put these things together in collections now, you know, representing things like an array of people's heights, or an array of test scores, or an array of stock prices, or something like that. Python uses the list built-in data type to keep track of array or vector-like things in a sequence, and you can define a list by enclosing a comma-separated sequence of values in a pair of square brackets. So what I'm doing here on slide 14 is I'm saying M gets a list containing 7, 2, 3, and 0. Okay, so if I just ask to see what M refers to, I get the list displayed. If I ask what is the type of M, I get told that thing is a list. And it turns out I can access items within this list as though the list were like an array in some other language. I can say M sub 1, for example. Now, lists in Python are actually indexed from 0. The very first item in the list is the sub-0 item. So when I say M sub 1, that's actually going to fetch and give back to me the 2 that's in the sub 1 position. Okay? So if your list has n items in it, then the individual items within the list can be indexed from 0 up to n minus 1. Now, Python, unlike a lot of other C language-like languages, also allows you to use reverse index. And here, minus 1, it turns out, is the index of the last item in the list. So my list has 4 items in it, 7, 2, 3, and 1. M sub minus 1 is a negative index that accesses the 0 at the end of the list. All right, and M sub minus 2 is the second to last item in the list. And since this list has 4 items in it, the fourth to last item, M sub minus 4, is going to be the same as the sub-0 item. Okay, so this list has 4 items in it, and I can either count forward with subscripts from 0 up to 3, or count backwards from minus 1 back to minus 4. And it's kind of obvious to wonder, well, why? You know, why do I have 2 different ways of indexing this list? Well, one of the things that it's common to use a list for is to contain input that you get from a file or from a program. And if you read a whole bunch, if you read, let's say, a line of values in and create from that a list of integers, how long is that list? I don't know. I'd have to count it after I get it in. But what's the last item in the list? Oh, well, the last item is the sub minus 1 item. I don't even have to know how long the list is in order to be able to obtain the last item in the list by using the negative subscripts. Okay. If you access outside of the list boundaries, you'll get yelled at. It's very common if you have, such as here, a list of 4 items. It's very common when you're first getting used to Python to think that the last one of these would be M sub 4, but no. 4 is one too far. If 4 is the number of items in the list, you can only go from 0 up to 3. Likewise, I can't count backward to, you know, minus 8. I'll get yelled at if I try to. M sub minus 8 would be an item in memory 4 items before the beginning of my list, and that's not going to be allowed. Make sense? Okay, now we are allowed to modify the items that are contained within the list. What this, or the word that's used to describe this modifiability of a collection in Python is mutable. When you read the Python documentation and you look at documentation for various containers or collections of data, mutable means that you can change the contents of the collection, and immutable means that you can't change the contents of the collection. So, I have my list M, referring to this list of 4 items, and if I say M sub 2, that will get and give back to me the 3rd item from the list. I can also say M sub 2 gets, let's say -4, to change the value in the sub 2 slot. Okay, so there I have changed one of the items in the list. I have therefore obviously modified the list, and because that didn't yell at me, I know that, okay, yeah, a list is mutable after all. And in fact, I can do things like saying M gets M plus, let's say 1, 2, 3. Now, here, the plus symbol for lists is concatenation, like it is for strings. The current contents of the list is the 4 values 7, 2, -4, 0. And actually, let me not do the M gets. Let me just say M plus 1, 2, 3. That concatenation is going to be computed, and the result is going to be displayed on my screen by the shell. M is actually not going to be changed in this case, though. So what I'm going to get as output on my screen is a list of 7 items, 7, 2, -4, 0, 1, 2, 3. But M itself has not been changed. If I want to change M, I could modify the M variable to refer to that concatenation. Okay, so this statement, M gets M plus the list 1, 2, 3, says, get me the list that M refers to, which is 7, 2, -4, 0. Concatenate to that list the values 1, 2, and 3. And now that I've got this list of 7 items, let's have M refer to that list instead of the list of 4 items. So now M is referring to this new longer list compared to the original 7, 2, -4, 0 list that it was referring to. Okay? Repetition makes it really easy to create big lists of values that are all the same. Let's imagine that you were writing a program that needed to count the number of occurrences of certain inventory items. You know, you've got matchbooks and light bulbs and bars of soap, and you need to count all of these things. Well, if you've got 1,000 things that you need to count, you can initialize your counters to 0 times 1,000. All right. So instead of having to manually type out 0, 0, 0, 0 and figuring out to do that 1,000 times, you just say, well, I want counters to refer to a list of 1,000 zeros. And now I've got my list of 1,000 zeros just fine. Okay, so we create lists using square brackets. We can access individual items in lists. We can also modify lists. List is a mutable collection type. Good so far? All right. In addition to these symbolic operations like the assignment operator and the star and the plus, the list collection type has a bunch of named so-called methods. Method is the object-oriented word meaning a function that operates on an object. And for example, I can say, given my m variable here, hey, come here, m. Okay, so m now contains these 7 values. I can say m dot append some value, and that modifies the list to contain another value at the end of the list. Or I can use insert to insert a value anywhere in the list that I want. Now, append always means at the end, but insert can go anywhere. I can say m dot insert ahead of position 0, a -6, let's say, and that put a -6 at the front of my list. This index can be any valid index from 0 up to, in fact, the whole length of the list. Now, m at this moment has 9 items in it. So if I directly tried to access m sub 9, that subscript is one too far, and I'll get yelled at. All right, m sub 8 at this moment is the last item in the list, whose value is 9. But with insert, I can say m dot insert 9, and let's say another -6, because the index that I give to insert is the index ahead of which I want to put my value. Okay, so 9 itself is past the end of the list, but if I insert ahead of 9, that will give me a new value in the 9th location. And so m now contains 10 items from m sub 0 up through m sub 9. And if I wanted to put a value in the middle, I'd say insert, I don't know, 4, let's say -3. And so let's see, so sub 0, sub 1, sub 2, sub 3, sub 4. Okay, so the sub 4 item is the 0, and what I've done now is I've inserted the -3 ahead of that sub 4 item. So I've now got a -3 ahead of the 0. Everybody good with insert? Okay. We can get rid of a value by using remove. So I can say m dot remove 2, let's say. And there are 2 occurrences of 2 in this list. Remove only removes the first one. Okay, so the one that used to be between the 7 and the -4 is now gone. The one between the 1 and the 3 is still there. If I try to remove a value that doesn't exist, I get yelled at. Okay? So if the value does exist, you remove the first occurrence of the value. If the value that you asked for does not exist, you get yelled at, and the list isn't changed. The list still has what it had before. The pop named member function returns one value from the list and also eliminates that value from the list. Now, by default, pop will remove the value from the end of the list. So here's m, and if I say m.pop with no argument, that means it's going to take the -6 from the end and return that value to me. If I say m.pop again, I'm going to get the 9. m.pop again is going to return the 3. And when I look at m, I'll see that the -6, the 9, and the 3 have all been removed from the end of m. I can count how many times a value occurs in my list. I can also sort the items in the list, and the default here is to put them in ascending order. So let me append a couple more values here just so I have something to work with. Okay, so here's my m, and if I now say m.sort, m itself is going to be modified so that the values are in ascending order. Now, technically, the values are in non-descending order. I mean, going from -6 to -6 is not technically ascending, but it is non-descending. And likewise, going from 1 to 1 is non-descending. So I've got my list in ascending order. Make sense? And reverse, whoop, is just going to change the, it's just going to reverse the order of all of the items in the list. Okay, altogether, it turns out that there are 11 different named operations that you can use to interact with lists or with individual items within the list. And here we've shown you 7 of the common functions that people use. Now, I'm going to advise you, no, I'm going to tell you that you should know these. All right. When you're starting out with a new programming language, you're going to be just presented with a lot of facts. And the facts are frequently not very interesting and not very entertaining to learn. But unfortunately, they are really important. Like if we were talking about how to build a house, I would have to make sure that you know how to use a screwdriver, and you know how to use a saw, and you know how to use a hammer, and you know how to use a well, you can tell what carpentry I am familiar with. I know 3 tools, apparently. You have to know how to use the basic tools without even really thinking about it. So you have to know now ints, floats, stirs, and bools. You have to know about arithmetic. You have to know about assigning values to variables. And now you're going to have to know about lists. And you're going to have to know the symbolic operations on lists, like plus and star, and these named methods on lists. And at first, this is going to seem annoying, but as you start writing code, as you start writing programs, you'll just sort of start naturally using lists. Oh yeah, I'm getting values from here. I want to get those values and put them in a list, and I want to have that list sorted, and then I want to get rid of all the negative numbers. And you'll be thinking at this fairly high conceptual level about what you want to do, and your fingers, well, your brain is involved, but your fingers are going to say, oh, well, that means I need to build a list, I need to sort the list, I need to remove values from the list, and you'll know these things instead of having to Google for them all the time, right? So I'm gonna expect you to know these things. So far, so good? Okay. And so here on slide 19 are similar examples to ones that I did live. Now, a list is a built-in example of what generally is called a class, a higher-level data type. We've got our low-level scalar types, int, float, bool, stir. And from these, we start building higher-level data types like lists and sets and dictionaries and so on. And features of a class, so-called, include having a very well-defined interface for creating objects of the class, accessing objects within the class, storing objects into the class, and then deleting objects from the class. And we've shown examples of all of those things with the list. We've got, you can just use the square brackets and an equal sign to create the list. There are other ways of creating lists too, but that's one. And we know how to add values to the list. We've got append and insert. We know how to find out about values in the list. We can use subscripting, we can use counting, we can use popping. We can get rid of values in the list. We can use remove. And we can also do things like sorting the list and reversing the list. So we have this very well-defined collection of interface functions for manipulating lists. And importantly, we don't have to write the functions that do that ourselves. Now, in many languages, like good old C, an array is just a sequence of values, and an array is a very passive thing. And if you want to count how many times a 5 occurs in an array, you have to use a loop to step through and figure that out yourself. And if you want to sort the values in an array, you have to call a sorting function that knows how to access an array and swap the items in that array around. So what classes do is to sort of pull the conceptual level of your interaction with programming up to a higher level where these data types actually have the appropriate facilities built into them, so that you don't have to write your own low-level functions for messing around with low-level data types. The data within an object is often referred to as the state of the object. So my M now, the current state of M here is that it contains 10 values in this particular order. We often think of what we're doing in object orientation as trying to lift the language up to the level of the problem that we're working at, so that we're dealing with, for example, inventory in a store, or stocks and bonds and options and mortgages in a finance program, or employees and managers and directors in a human relations program. We're dealing with things at that conceptual level instead of having to take all of our concepts and shove those down into ints and floats and bools and stirs and dealing with really low-level things. All right. So now I've told you everything that you possibly need to know about object-oriented programming on a single page. Any questions? Okay, we'll talk some more about this as we go. I'll sort of keep reminding you. Okay, so like I said, we want to be able to write our code at the level of our concepts. We want to deal with people, employees, managers, stocks, bonds, mortgages. And there are hierarchies of things involved, which in object-oriented terms is called inheritance. So if we thought about stuff in a grocery store, we would have bars of soap, we would have tubes of toothpaste, we would have bottles of shampoo. Collectively, those things are all, health and beauty aids. So a health and beauty aid is a class of thing, and then a bar of soap is a kind of health and beauty aid, and a tube of toothpaste is a kind of health and beauty aid, and so on. So object orientation also sort of keeps track of this hierarchical relationship among types as well. All right, well now we're going to descend from 30,000 feet and come crashing back down to low-level Python stuff once again. When you write Python statements, such as an assignment statement, the statement has to exist on a single so-called logical line. And if you have something like a function that you've defined, or if you have something like an if decision that you've defined, which we don't know how to do that yet, but we'll see it very shortly, or a loop to define, in a function or a decision or a loop, you can create these things called compound statements, which are simply a sequence of these individual statements. Now, Python is annoying among modern languages is that in addition to this idea of logical lines, Python also has a separate notion of physical lines. A physical line is anything that you type on your keyboard that ends with the enter key. And most of the time, if your Python statement is short, you can fit a logical line into a single physical line with no problem. All right, so here I'm saying x gets 12. X gets 12 is my logical line. Fortunately for me, it fits on a single physical line. Python is happy. I'm happy. I have a variable named x that refers to 12. But what if my logical line, what if the Python statement I'm writing gets so long that I have to split it to multiple physical lines? Now Python gets really unhappy with me. If I say x gets, and I decide, well, you know what, the next part of this is going to be so long, I want to type it on the next line down. Most languages would be perfectly happy for you to just press the enter key and keep going, but Python says, oh, no. This is a syntax error. You can't press the enter key there. So if I want to be able to press the enter key and continue my logical line on a second physical line, in Python I'm allowed to use a backslash and then press the enter key. And Python sees the backslash and says, oh, I get it. You're continuing the logical line on another physical line. Okay, I get it. And now I can say 12 and hit enter. And that's successful. I have now completed a logical line across two physical lines by using a backslash continuation mark before my second physical line. This is a pain. And most modern languages don't force you to use some kind of continuation mark if you have a statement that's too long to fit in a single physical line, but Python is that way. Fortunately, another way, all right, so slide 23 demonstrates what I just showed you live. Another way of continuing a long line is to just enclose things in a pair of parentheses or a pair of square brackets or a pair of curly braces, which we'll talk about later. So I can also say things like x gets 12 minus 3 plus 4. And as long as I've got those separate lines all enclosed in parentheses, Python is entirely happy. So I'm going to get, what, 13 here, I guess, as the value of x. All right, now I'm going to tell you that this annoys me enormously. Almost all modern languages are what are called free format languages, and all the languages care about is that you have you have your operations and your symbols in the correct order, and they don't care about spaces, they don't care about where you hit the enter key. You just have to have the correct things in the correct order. And yet Python has this stupid line continuation thing you have to do. Oh, except that there's a loophole. There's a loophole. You can use parentheses, and then you can type as many lines as you want. So people often use parentheses just for that purpose of allowing them to continue lines across, continue statements, continue logical lines across multiple physical lines. Similarly, I can define a list that's very long. Because it's enclosed in square brackets, I can define that in separate physical lines. Whoops, I forgot my comma, so I'll just type the comma there. Okay. So there again, I used this loophole, and Python was okay allowing me to type the definition of my list across multiple physical lines. Okay, so I wish I did not have to tell you about the difference between logical lines and physical lines, but I do. And so now you know. If you want to find out how long a so-called sequence is, len is a built-in function that will do that. So I can say, here's m, give me the len of m, and that will tell me that there are 10 items in m. I can also use len to find out how long a string is. So s here is 5 characters long. I can ask for the length of a literal string. This is a test of the len function. And len will tell me how long that is. So that's a function that you're going to use all the time to find out how many items a particular collection or sequence contains. Well, a very common thing to need to know how to do once you've been introduced to lists is, I've got this list of things. I would like to be able to do something with each item in the list. How can I please do something with each item in the list and have this work for lists that are, 2 items long or 10 items long or 1,000 items long? I want to be able to just step through all of the items in a list regardless of how long that list is. Well, this is what the so-called for loop is for. The for loop starts out with the word for. Then you give any variable name that you like, and that variable is going to take on one value at a time, the values of all of the items in your list in our case. Actually, list is technically just one example of something called an iterable. An iterable is like a sequence of things or a collection of things that you're allowed to go through one value at a time. All right, so for our first example, that will be a list. Notice that you have to have a colon at the end of that first line. And then within the body of the list, you can have as many statements as you like. But those statements all have to be indented at exactly the same level as each other. So I can do this. I can say for, all right, so here's m. I can say for j, well, k is fine too. For k in m, print the value of k. Now, the print function automatically is going to add something called a new line at the end of each thing that it prints. So the upshot of this little for loop here is that all the values in m are going to be displayed one value per line. All right, so 9 is going to be printed, and then I'll have a new line. And then 7 is printed, and I'll have a new line. 2 is printed, and I'll have a new line. And then 1 twice, and so on. So there is, let me stretch my window height just a little bit. So there is the output produced by this for loop, where I'm saying for this k, which is just going to take on the values in the list one by one, 9, 7, 2, 1, 1, 0, minus 3, print each of those values out one value at a time on a line by itself. How could I get those all on a single line instead of on separate lines? Any ideas? Well, we know about. Okay, so I guess I was trying to coax somebody to tell me about a feature we haven't talked about yet. So that wasn't very fair. But we've talked about the separator. Remember, we said sep equals comma could be used to separate the values in the list by some arbitrary character. There's another keyword called end, and if I say display the value of k and then have the end of the output be a space instead of the default, which is new line, now I will get all the values out on a single line. separated by spaces instead of having the default new line character displayed at the end of each print. Yeah?
And we just give a space and a string.
I'm sorry, can't we just give the space in a string? Is that what you asked?
Yeah.
Ah, let's take a look at that. So for k in M, print k, comma, and then like a space.
Yeah,
2 spaces? Okay. So we'll have a value and then we'll have 2 spaces. And unfortunately, what we're going to get is the value, 2 spaces, actually 3 spaces, right? Because we're going to get a space for the comma, then we're going to get 2 spaces from the string. But then by default, print is going to display a new line character. So we are getting a value and 3 spaces on each line, but then we get the new line, which drops us down to the next character, the next line. Good. Other questions? Yes.
How would you specify that you want to do a for loop for a subset of your list?
Excellent. All right. So are we gonna let me do this for loop for the string first. A list is one example of an iterable. I can also say for some loop variable in a string, and the string will be split up into a sequence of 1 character long strings. So now I can say print s to get 1 line per character, or I can say for s in hello world and use our AND trick. To get them all on 1 line. But how could I get just like a subset of the items in a list or in a string? For that, we need to know about, or one way of handling that question is to use a function called range as our iterable, instead of using the list itself or the string itself. Now, we know that we have this list M, and we know that, or we can find out that the length of M, the number of items in N, in M is 10. If I say for, let's say IDX for index, in range 5, let's say. Now, the range function, if I give just 1 argument, is going to produce for me a sequence of integer values starting from 0. So I'm going to get 0, 1, 2, 3, 4. The value 5 that I specified as my argument, that's 1 too far. So actually, I'm going to get 5 values, but the specific values are going to be 0, 1, 2, 3, 4. And now I can use that index to say print M sub I. And let's have and be a space. All right, so this idea enables me to just step through the first 5 items within M instead of all the items within M.
Or is it M sub
M
IDX?
Thank you. IDX, of course, yes, thank you. I'm glad I didn't hit the enter key and then discover I made the mistake. Good? Questions? All right, so I'll hit the enter key now, and there we go. The range function allows you to specify a beginning value as well as an ending value. So let's suppose that I wanted to print like the middle part of this list. I could say for IDX in range 2 comma 7, just for gags. Now 2 comma 7 means 2, 3, 4, 5, 6. So I'm going to get 5 values starting from 2 and going up to but not including 7. And I'll print, actually, so I don't make a mistake, I'll just copy and paste this guy. I tried. I hit the enter key or I hit the Control C by accident instead of Control V. So let's try this again. And I haven't made a big deal about it, but notice that this print statement is being indented. The shell, in my case, is doing the indentation for me automatically. But if I didn't have the indentation there, Python would yell at me. All right, so now I got the values from sub 2, 3, 4, 5, 6, but not sub 7. So I've got 2110 minus 3. It's also possible with the range function to specify a third parameter, which is a step size. The default step size is 1, so we go 0, 1, 2, 3. But if I if I specified 2 as my step size, then I'd go 0, 2, 4, 6 up to, but not including the limit. Because I can use step sizes and I can specify negative steps, it turns out that I can count downwards rather than necessarily upwards. So in this final example here on slide 29, I'm saying for I in range. All right, now I'm going to start from 10 and count down to, but not including minus 1, with a step size of minus 1 at a time. And I'll print I and a space instead of a new line. All right, so basically what we've got now is a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Yes?
Can we give range for floating point? Like range, can we put floating point inside the range?
I think so, actually. That's a really good question, and I think I've done that in the past. But I could be wrong. Well, it didn't yell at me yet. No. All right. Nope. Can't do it. But all is not lost because it's easy to convert integers to floating point, right? You just multiply by a floating point number. So I can say something like this: for I in range 10, x gets I over 2 print x. So if you can figure out an easy way to get from integers to the equivalent floating point numbers that you want, then you're all set. Okay, so we are 1 minute early. Amazing. So we looked at the base scalar types, int, float, stir, and bool. We looked at the idea that variables are references rather than variables containing values of types that never changed. We introduced the idea of lists and the idea of loops and the range function. Any questions? Alrighty.